And finally we have a curve y equals e to the power x, and it is rotated about the x-axis, and the x coordinates are given like this, right? Now when you have these equations, don't try to subject x from these stuffs, right? Then yeah, like you will have to introduce logarithm and things will be complicated than it seems, right? So just simply as they have already subjected the y coordinate, we will use dy by dx, right, for the ds term, right? And anyway, as we have a x-axis rotation, we will have to use the formula 2 pi y ds as our main formula for the surface area. And for ds, since we have dy by dx, we can use 1 plus dy by dx squared square root, and since this is dx, we will have to have dx here. And so remember, when you have dx here and y here, you will have to change everything back into x variables as well, right? So once you have this one, we have an integral that runs through the variable x, but here we have mentioned y. So instead of that y, you will have to represent y in terms of x. So our equation will become 2 pi ex 1 plus dy by dx squared with respect to dx. And as we have the equation as y equals ex, then dy by dx will also be equal to ex, right? And now since we have the integral with respect to x, our two limits should also run through the variable x, and anyway they have given the limits in terms of x, so simply you have to mention the two lower and upper limits, right? The two limits. Okay, so once you have all these things with your integral, it's just a matter of computing the integrals with the techniques that we have learned so far. So the integral will be like this, right? And once you substitute ex here, you will have to use this substitution to integrate this integral. And I recommend you to do all these intermediate steps, right? It will give you a very good practice in the methods that we have done so far, right? And to compute this one, we will need the tan substitution. And for this one, remember, we came across this integral in a previous example of this week, right? It is in the previous videos. And this one we did in example 7.2.8. You can see it in the book as well as in the videos for the section 7.2. And this technique also we did in the previous videos of this week itself, right? So we know this technique. We have obtained the value for the sec squared alpha from this trigonometric identity, and substituting everything, you can get this as the final answer. And remember, tan alpha is equal to E because alpha is considered as tan inverse E, right? We did a very similar calculation in a previous video of this week's video sessions, right? And I'm saying it again, please do all these intermediate steps including these examples, right? So that will give you a very good practice on integration, right? So this will conclude the videos for the week 4.